Think about the shirt you're wearing right now. It feels pretty simple, right? It's just a piece of fabric. But the journey of the threads that make it up is unbelievably complex. And for centuries, that journey has been plagued by tiny, tiny mistakes that have absolutely huge consequences.
But what if, just imagine, we could get rid of those mistakes for good? What if every single shirt, every pair of jeans could be woven to perfection with zero defects and, get this, zero waste? I know it sounds a little like science fiction, but it's a problem that engineers are actually solving right now.
I mean, for as long as we've been making clothes, defects have just been part of the deal, and that's led to millions of tons of wasted material. But now, a whole new wave of technology, everything from super advanced simulations to artificial intelligence, is completely changing the game, right from the thread up. Okay, so let's get into the real heart of the issue. To understand the solution, you've got to understand the problem. And in the world of weaving, it all comes down to what you might call the Goldilocks factor. Finding the conditions that are just right. The key variable we're talking about here is something called warp tension. So in any loom, you've got these lengthwise threads called the warp, and they're held under tension. A good way to think about them is like the strings on a guitar. And the amount of pull on those threads, well, that is the single most critical thing in the entire process. And here's where it gets really tricky. That tension, it has to be perfect. If it's even a little too high, pop! The yarn snap and the whole multi-million-dollar machine just grinds to a halt. But if it's too low, the threads can jam up and you start weaving flaws and defects right into the fabric itself. It's this constant, delicate balancing act where one tiny error can ruin absolutely everything. So how do you even begin to solve such a delicate physical problem? You can't just keep guessing and throwing away material, right? So researchers decided to come at it from a totally different angle. They thought, what if we take the loom out of the factory and put it inside a computer? They set out to build a perfect digital copy of the real thing. So they created what's called a digital twin. First, they had to model all the incredibly complex physics of the weaving process. I mean, every little movement. Then they built a software simulation that could calculate the warp tension at any given split second. But here's the most important step. They had to test it against a real loom to see if their digital creation was even accurate. And wow, just look at how close they got. On a real-world weaving machine, they measured the average warp tension at 132 centinewtons, which is a super tiny unit of force. Their simulation, it predicted a tension of 130. I mean, that is an incredibly, incredibly close match. This was the big breakthrough moment. They had basically built a digital crystal ball for the whole weaving process. They could now accurately predict what was happening to a thread without ever having to touch the machine. But, predicting a problem is only half the battle. Now that they had this validated simulation, researchers basically had a digital sandbox to play in. So they unleashed these powerful optimization tools. Things like genetic algorithms, which are basically programs that just test thousands and thousands of possibilities to evolve the best solution. They let it run wild to find the absolute perfect machine settings. And this just shows you the results so perfectly. Before, the tension was all over the place, it was spiking and dipping, putting all this stress on the yarn. But after they applied the settings the algorithm found, the tension became so much lower, and just look how consistent it is. They had found the perfect, stable, sweet spot for weaving. So, what happened when they took these new settings and put them on the actual physical loom? Well, the results were immediate, and they were dramatic. In a 3-hour test run, the fabric defects that had been constantly popping up before, they just disappeared, vanished. This whole simulation approach was revolutionary, but that was in the lab. How do you take that same intelligence and apply it to a noisy, super fast-paced factory floor in real time? Well, that's the next step in this evolution, and it's where the AI quality inspector comes into play. So you've got companies like SmartTex who are building the tools for what they call the modern textile factory. They're actually mounting these high-speed cameras and AI systems right onto the machines. And these systems don't just predict problems, they see them as they're happening, monitoring every single thread for any little abnormality. And this isn't just about efficiency or saving money. It's about peace of mind for the people who actually run these incredibly complex machines. As one operator said, this tech gives her the confidence to know that her production line is running smoothly, without making mistakes. So what kind of tiny mistakes is this AI actually finding?
Well, if you look at the data, the vast majority, we're talking 63%, are tiny mechanical issues with the needles. Another 30% are actual faults with the yarn itself, and the rest are things like oil stains or tiny holes. These are all things that a human eye might have totally missed until it was way too late. And the impact here is just staggering. In one case study at a major manufacturer, putting in this AI-driven system led to a 50% reduction in the number of fabric rolls that needed a slow, manual quality check. 50%! The AI is like a tireless, super vigilant set of eyes on every single machine. So where is all of this tech headed? What does it really mean for the future of how we make things? Well, we're moving away from factories that just follow instructions, and we're moving toward factories that can actually think. When you put it all together, the big takeaway is crystal clear. We've seen that a tiny physical detail, like the pole on a single thread, can have massive economic and environmental costs. But we've also seen how digital twins can predict these complex problems, and how AI can step right in to prevent them in real time. The end result? We're looking at a future with higher quality products, way less waste, and a much more sustainable way of making the clothes that we all wear every day. And that leaves us with a pretty fascinating final thought. We are entering an age where the machines that make our stuff are becoming intelligent. They can sense, they can predict, and they can self-correct. So what does it mean for us when the factory itself knows more about the quality and the history of your clothes than you do?